everyone, Miss Pak from Mirror Lake. Thanks for joining us today. Let's dive right into our target or our focus for the day. Go ahead and read that with me. Ready? I will use strategies to understand the meaning of words. One thing we're going to focus on is plug it in strategy, which we've tried before if you've tuned in before, and use a synonym in place of it, which is a word that means the same thing. So let's get started. Here's a quick little chart to help us focus today. We want to look for context clues when we come across a word that we're not sure of. Clues that good readers use to find the meaning of unknown words. So here's some examples. One thing is to look at the pictures and see if that helps us with any of the words. Sometimes there's helping words such as or, like, are, or called. Words you already know in the text. And then the one we're going to try and do is plug it in, a synonym, words that mean the same, or an antonym, which is words that mean the opposite. You guessed it. So before we actually get started into our story today, let's do an example using this. All right, here's a true story. Go ahead and read that sentence with me. Miss Pak loves hand sanitizer. She uses it every day and keeps it in her car too. It is a necessity. First thing for good readers, is there a word on there that you're not really sure of? I wonder if you chose the same one I did. Was it the word necessity? Awesome. Me too. So that word there, as a good reader, I'm thinking in my head, I'm not really sure what that word is, but let's use those context clues or clues around the text to help us. So let's read that again and see if we hear any clues. Miss Pak loves hand sanitizer. She uses it every day and keeps it in her car too. It is a blank. We want to try and plug it in and find a word or a short phrase to plug it in and see if we understand what it means. So there's a clue here. Maybe I love hand sanitizer and I use it every day. Oh man. And I keep it in my car too. Holy cow. So it's all over the place. It's also in my purse, kept with me too. It is a necessity. So like I said, we can plug in a short phrase also. It doesn't just have to be a word. So I'm wondering what you're thinking. I wish I could hear your thoughts on what you're thinking this word is. Do you think I like sanitizer? That should be an obvious yes. Do you think I think it's important? Yes, I would say so, that it is important to me because I love it, I use it every day, and I keep it in my car. So I know this doesn't quite fit with A, but it is important. Let's try that. Plug it in, see if that makes sense. Ready? Miss Pak loves hand sanitizer. She uses it every day and keeps it in her car too. It is important. Does that fit? That sounds like it fit to me. And these supporting words help me to know and understand that this word does mean important. And I use some of the clues in that text. Nice job. So today the story we have is a picture book of Cesar Chavez by David Adler and Michael S. Adler. So we're going to be looking for those clues today, the context clues. As a child, Cesar Chavez traveled with his family from one farm to the next to pick beans, broccoli, lettuce, and other crops. After a day in the fields, his back often ached. His hands were sore, yet Chavez and others who helped put food on Americans' tables often had no tables of their own, no real homes. Later, Cesar Chavez could lead the fight for better pay, working conditions, and health care for families such as his. Let you see the picture there. Cesar Chavez was born on March 31st, 1927, near Yuma, Arizona. His parents, Librado and Juana Chavez, were farmers. Cesar was the second of their 5 children. Caesar's father was often too busy to spend time with his family. It was Caesar's mom who kept them together. She told her children stories. She taught them values and many proverbs, such as, "What you do to others, others do to you." Caesar woke up early each morning and did the usual farm chores. He carried water from the nearby canal, fed the animals, and gathered eggs. Then he went to school. I wonder if those chores are the same as yours. The Chavez family spoke Spanish at home, but in school, whenever Caesar spoke Spanish, his teacher hit him. "It's a terrible thing," he later said, "when you have your own language and customs, and those are shattered." I bet there's lots of you who speak a different language also. Cesar Chavez grew up during the Great Depression. People everywhere lost their jobs. In 1938, Caesar's parents lost their farm and moved to California. Caesar's father soon found work for the family picking peas. They walked, bent over, between the rows of plants. For a full hamper, 25 pounds of peas, they earned 20 cents a day. That's not a lot. When the work on that farm was done, the family moved on. They picked string beans, lima beans, broccoli, lettuce, sugar beets, cauliflower, onions, carrots, tomatoes, cantaloupe, watermelon, and grapes. When the farm boss was especially unfair or when work conditions were especially bad, Caesar's father said, "Okay, let's go." They quit. Caesar Chavez later remembered, "Our dignity meant more than money." Man, look at them all hunched over and in the hot sun for not very much money. The Chavez family, like many others, had no real home. One winter, with nowhere else to go, they slept in a tent in a woman's yard. The family moved around so much that Caesar attended 65 elementary schools, some for just a day or a week. Yes, I said 65 different schools he went to. In 1942, after his father was hurt in a car accident, 15-year-old Caesar dropped out of school to earn money for his family. In 1944, in the midst of World War II, Cesar Chavez enlisted in the U.S. Navy. He served for 2 years. While on a short leave, he went to a movie theater in Delano, California. The theater was segregated. African Americans, Filipinos, and Mexicans were confined to a section on the right. Cesar Chavez felt this was wrong. He sat on the left and was arrested. "In our own way," Chavez said later, "my family had been challenging the growers for some time. Now he was challenging a theater owner." Just like his dad, he's sticking up for what he believes in. So I see the word enlisted right up here, and I'm wondering what that means. In the midst of World War II, Cesar Chavez blank in the U.S. Army. Then he served for 2 years. What do you think that could mean, the word enlisted? I'm thinking that he went to the U.S. Navy, or he chose to go to the U.S. Navy, and he served for 2 years, meaning he wanted to help in the U.S. Navy. After his discharge from the Navy, Chavez began dating Helen Fabula, a young woman from a family of farm workers. Helen worked in a local grocery store, and Chavez went to the store often just to see her. They married in 1948 and soon moved to San Jose, California. They had 8 children. In June 1952, Chavez met Fred Ross, who had been sent to San Jose by the Community Service Organization to register voters for the coming elections. "He changed my life," Chavez says. Ross explained how in the United States, even poor people had power. They just needed to speak out to vote. Chavez was convinced and went door to door and urged people to register to vote. At first, he was so frightened he couldn't talk. "Little by little, I got confidence," Chavez said later, In about 3 days, I was doing okay. I see a word here. There might be a few words you're not sure of. That's okay. But I'm going to look over here and I see the word urged. Let's look at some of those context clues, remember? See if there's any pictures or helping words or words we know to try and plug it in to find a different word. So I see that he's talking to a bunch of different families and people. So let's read that again. Ross explained how in the United States, even poor people had power. They just needed to speak out to vote. Chavez was convinced, that means he believed what he said, and went door to door and blanked people to register to vote. What do you think he was doing? If he went door to door, and I'm thinking, man, he wanted people to register to vote. Does that fit? Let's plug that in. They just needed to speak out to vote. Chavez was convinced and went door to door and wanted people to register to vote, or strongly suggested people to register to vote. Notice when I'm plugging something in, I don't just plug it in. I read the sentence before and after to see if it makes sense, and I see some clues there that help support that. Chavez talked and argued with people and would not give up until they agreed to register. Soon, he was hired to start CSO chapters throughout California. Here's a picture for you. In 1958, he went to Oxnard and asked the farm workers there to register and vote. They asked him, "Why is it we can't get any jobs?" The jobs were going to workers from Mexico who accepted lower pay. Chavez organized a march. Reporters came and saw Chavez stand on the hood of a car and speak to the out-of-work farm workers. After a 13-month struggle, the Oxnard fruit growers gave in and hired local workers. Here's the picture. In 1962, Chavez left the CSO and formed a fruit pickers union, the National Farm Workers Association, NFWA. By 1965, it had 1,700 member families. California grape pickers were paid about $1 an hour, which was not a living wage. From that dollar, some growers charged the workers, who spent all day in the hot sun, for every drink of water they took. So imagine that. Anytime you took a sip of water at school or drank something, they would charge you and take that out of your hard-earned money. In September 1965, workers in another union began a strike against grape growers in Delano. Chavez's union joined them. The two unions merged, forming the United Farm Workers Organizing Committee, UFWOC. I see that word merged here. The two unions merged, so blanked, forming the UFWOC. I'm looking at the pictures as well, and what does it look like they're doing? What do you think? It looks like they're coming together. I'm sensing that the word means merged, coming together. And let's see if that makes sense with the words around it. Chavez's union joined them. So joining is like coming together. And the two unions merged, forming this one. So two came together to form one. Chavez organized church meetings, sit-ins, and even a 300-mile march of underpaid California grape pickers. When all that failed, he called for a nationwide boycott of California grapes. Remember boycott? That means giving something up. In February 1968, in protest, Chavez stopped eating. For 25 days straight, he drank only water and diet soda. His followers rallied behind him. Caesar's fast ended at a public mass and celebration. "I was so much out of it," Chavez said later. "All I felt was a lot of people pushing and trying to get closer. I was being held up because my legs were so weak from not eating for that long." Senator Robert F. Kennedy gave Chavez a piece of bread to eat. "I come here as an American citizen to honor Cesar Chavez," Kennedy said. "I honor him for his compassion, his honesty, his truth, and dedication." The strike and boycott ended in July 1970 with higher wages and health care protection for members of Chavez's union. Chavez wasn't done fighting for poor farm workers. In August 1970, he called for a boycott of lettuce, and when he refused to end the boycott despite a court order, he was thrown in jail. In 1972, he fasted for 24 days to protest anti-union laws. He organized a massive voter registration drive that helped defeat those laws. Chavez knew that poisonous chemicals sprayed on grapevines to keep away insects were injuring farm workers. In 1987, he called for a boycott of all grapes sprayed with dangerous pesticides and fasted for 36 days. That word means he didn't eat again, in support of the boycott. In the years ahead, laws were passed to limit the use of these chemicals. So he is standing up for what he believes in. Here's that picture. In April 1993, Chavez died in his sleep while on union business in Arizona. American farm workers had lost their greatest champion. In accordance with his wishes, he was buried in a simple pine box. More than 40,000 people marched in his procession. 1 year later, Helen Chavez accepted the Presidential Medal of Freedom, the nation's highest civilian honor, for her husband. At the ceremony, President Bill Clinton said, "This remarkable man, with faith and discipline, with soft-spoken humility and amazing inner strength, led a very courageous life. And in so doing, he brought dignity to the lives of so many others and provided for us an inspiration for the rest of our nation's history." How many of you have heard of lesson or central message of a story? Let's see if we remember what a lesson is. Do you remember what a lesson is? It is what the author wants me to learn. So based on that book, why would the author write make a picture book of Cesar Chavez for little kids to learn? What do you think? There's a couple different lessons, and remember, if you don't have the same exact one as mine, that's okay. Just make sure that you have evidence that supports it as well. So here's one I thought about, and I wonder if you're thinking the same lesson for this story. What did the author want me to learn based on reading about Cesar Chavez? So one was never give up. Would you agree to that? I agree. Caesar really showed that he did not give up. And also another lesson could be fight for what you believe in. Do you agree? That's a lesson of the story. Now, just to be sure, we want to make sure that we have some evidence from the text to prove that this is the lesson of the story, or this could be an example of the story. So here's a couple pieces of evidence that I already pulled for you guys, and you tell me if you think that fits. So here's evidence that supports the lesson. Can you read this with me? Caesar continued to lead peaceful protests. So that shows he never gave up or he was fighting for what he believed in. Another example could be Caesar was willing to get arrested. Man, that is totally not giving up and fighting for what he believes in, or standing up for what he believes in. And the last example I found was he had hunger strikes for himself and other farm workers. And that eventually brought attention to the nation, and thousands of people were following him. So he never gave up, and he also fought for what he believed in. I think that was a good lesson, something we can learn from that story.
Hey everybody, welcome back for another summer third grade math lesson. This is Mrs. Nelson. We've been working together these past couple weeks, and this week we have been talking about properties or rules of multiplication that we can learn, remember, and use to help us solve multiplication and division equations and word problems. So kind of like we're digging into some more strategies. but it's also helpful because these are rules that are always true and they always work. For example, on Monday, we talked about the commutative property. The commutative property is just the rule that says that we can switch the position of our factors around, or the order of our factors, and the product, the total, the answer will always be the same. So in this example here, 2 times 4 is equal to 8, and so is 4 times 2. And that was on Monday, the rule that we kind of talked about and used and practiced. On Tuesday, yesterday, we talked about the associative property rule, which says that we can, and this was special for multiplying 3 numbers, 3 factors. And this rule says, the associative property says, when we are multiplying 3 numbers or 3 factors, we can group the factors together and multiply any 2 factors for the first step, then multiply that product by the last factor, and we will always get the same product, the same final answer, no matter what order we do that in. So like up here, we could do 3 times 4 first to solve 3 times 4 times 8, or we could do 4 times 8 first. And then at the bottom, or on the back here, I have another example for trying to solve 4 times 2 times 5. And that was what we talked about yesterday, was how we can use the associative property to remember how to multiply. So today we are going to dive into a new property, a new rule that we're going to explore and use. And I really like this property. It's called the distributive property. And we can use this property as a strategy for solving harder facts or equations or expressions that have larger factors. So think about solving problems like when we're multiplying times 7, times 8, times 9, and so on. This strategy, this property or rule is really helpful for solving equations like that. So that's what we're working on today. And in a moment, I will show you the whiteboard with our learning target. Before we get to that though, one thing we're gonna do a little check on is our background knowledge on how to break apart a number. So start thinking about that and what I might mean by that. And I'll see you again with the whiteboard. Mentioned, we are first talking today a little bit about how to break apart a number. I want you to think about, with any number, that we can, usually with bigger numbers, make a bigger number from 2 smaller numbers. So here, I'll give an example. Think about the number 8. Think about all the different ways you could add 2 smaller numbers to make a total of 8. For example, I know I could add 1 and 7 to make 8. Can you think of another example? Did you think of maybe 2 and 6? We can make 8 with 2 and 6. Oops. How about 3 and 5? Or another way we can break 8 apart would be 4 and 4. So when I say break apart a number into 2 smaller numbers, that's what I mean. Think about all the different numbers you could add together to make that bigger number. And the reason I want us to think about that today is because the distributive property, which is the rule that we're exploring today, means we can take one of the numbers or factors in an original multiplication expression, and I'm going to talk a little bit more about that word in a second, and we can break that factor into 2 smaller numbers, and we can turn our original equation into 2, or original expression, our original problem that we're solving, into 2 smaller, maybe friendlier facts to solve, then add those two products together and use that as a strategy for solving that original expression or equation. So by the way, the word expression just means a number sentence that does not have an equal sign. So on the screen here, 4 times 6, that would be an example of an expression. And I've been using the word equation a lot when I talk about our number sentences, because an equation is an expression with an equal sign. And that's usually the answer comes after the product would be the number we put after the equal sign in an equation. So anyway, today we are thinking about distributive property, breaking one of our factors apart into two smaller factors to make an equation a little bit easier to solve. I wanted to go through some important vocabulary words and just make sure we're feeling good about the meanings of each of these words. So instead of having the word wall in the corner today, I thought we could just look up the word wall really quickly on its own. So we're doing some multiplication today, working with multiplication problems. And that just means we're putting or adding equal groups together to find a total. The product is what we call the answer to a multiplication equation. The factors are those numbers that we're multiplying to find the product, the total. An equation is just a number sentence with an equal sign. And an expression, that word I used earlier, is just a number sentence that does not have the equal sign. So, for example, 4 times 2. Parentheses was a word we talked about in our last lesson, and that is just that symbol that are two curved lines and they kind of go around parts of an equation. And when you see parentheses in math, it means whatever part of the equation the parentheses are around, that is the step we do first. So just wanted to quickly go through those important words today so we remember what they mean as we're using them. So as I mentioned earlier, distributive property is all about breaking apart one of the factors in an original expression or equation in order to make the original problem easier to solve. And I mentioned that it can be really helpful when we're solving our facts like our times 7, times 8, times 9 facts. So this example I'm going to use is a problem that has a times 9 that we're going to think about. So 4 times 9. When we use the distributive property, we pick one of the factors to break apart. And it works either way, but the trick is you can only break apart one of the factors. So you have to pick which one you want to use. In this case, because 9 is the bigger factor, I think breaking apart the 9 will help us solve this. So I'm going to think about what two numbers could I put together to make 9 that when I multiply by each of those numbers, it makes it a little easier to solve. For example, I know when I'm solving a times 5 fact, I can use count by 5, skip counting by 5s as a strategy. So if I think about the number 5, what plus 5 makes 9? How could I break 9 apart into 5 and another number? Well, I know that 5 plus 4 is equal to 9. So I'm going to rewrite this original equation by breaking that 9 apart into 5 and 4. And the factor that I did not break apart is 4 up here. That stays the same, and that factor gets to jump down. And with each of those numbers I broke the 9 apart into, now I can solve those parts. 4 5s, figure out how much that is equal to. 4 4s, 4 groups of 4, figure out how much that is equal to. And then I can add those two products together to get my answer for 4 times 9. So using a strategy we've already practiced from a couple weeks ago, like counting by 5s, I'm going to solve first 4 times 5. So if I want to count by fives 4 times, I would say 5, 10, 15, 20. So 4 times 5 is equal to 20. So I'm just going to write 20 right there. Remember, we're going to add that to whatever the product of 4 times 4 is. So now I get to think about 4 fours and what kind of strategy do I want to use to solve that? And I think I'm going to use repeated addition for 4 fours. So I'm going to add, I'll just write it up here a little smaller, 4 plus 4 plus 4 plus 4. And when I'm adding 4 plus 4, I know that's equal to 8. So another 4 plus 4 is equal to 8. 8 plus 8, I know, is equal to 16. So now my last step, since I am almost finished, is just adding the two products that I got, 20 plus 16. And that is equal to 36, which means that 4 times 9, that original problem I was solving, is equal to 36. The learning target again is we will today use the distributive property to multiply. And the way that we know we're successful with that is showing that we can break apart one factor in a multiplication equation into two smaller factors and keep the other factor the same. And we will solve the two easier equations by multiplying each of the smaller factors by the factor that stayed the same. Then after that, we can add those products together to solve the original equation. So that's what I showed on my whiteboard. To look at the distributive property and think about what it looks like. When we're breaking apart one of our factors, you can kind of think about it as breaking apart the array. So if we, here on the screen, you see the equation 4 times 6 equals blank. Down below, this shows an array that is 4 rows of 6 flowers in each row. So this would be the original array to match 4 times 6. When we use distributive property, we can break apart one of those factors. And in this example, we see that they've broken apart the 6. So down below, instead of having 4 rows of 6, they now have an array over here that shows 4 rows of 5, and then a little array here showing 4 rows of 1. You can also think about these as 5 columns of 4 and 1 column of 4. But either way, the number that they broke apart, the factor that they broke apart was 6, and they broke it into 5 and 1. So if we solve for 4 fives, 4 rows of 5, and 4 ones, 4 rows of 1, and we added those together, we would get the total for 4 times 6. And so really quickly we can do that. If you look at this part of the array and we count by fives, we can see there are 5, 10, 15, 20 little flowers on that part of the array. And then on the other side, we only have 4 flowers. And we can do 20 plus 4 to solve 4 times 6. Of how we can use distributive property, and we have some carrots, an array showing rows of carrots, and this array is representing 3 times 6, so we have 6 rows of 3 or 3 columns of 6. Remember the commutative property, we could switch those numbers around, it wouldn't change the total. So either way you look at it. And in this example, the reason I wanted to look at it is because I mentioned before we can use distributive property to break apart the bigger factor, but you don't always have to break apart the bigger factor. You can also think about how to break apart the smaller factor. So in this example, the smaller factor would be 3. And so in this array, they're showing how instead of having 6 rows of 3, you could break it apart into 6 rows of 1 over here, and 6 rows of 2 carrots over here. So they broke, in this example, they broke apart the 3 into 1 and 2. So in other words, they broke apart 3 times 6 into 1 times 6 and 2 times 6. Another way to think about this, remember that when we think about multiplication, we're thinking about equal groups. So 3 times 6 is like 3 sixes. And in order to figure out how much I have altogether, if I have 3 sixes, I can think about how much I have if I have 1 6, one group of 6, and I put it together with 2 more sixes. So just thinking about how we're breaking apart the factor 3 here, and it also is a way to look at it with a different array. I wanted you to see that so you know that you can use distributive property and break apart the smaller factor. In this case, 1 6 would be 6, 2 sixes would be 12, and so we can use 6 plus 12 to solve for 3 times 6, and that would give us an answer of 18. To try using distributive property to break apart one factor from a multiplication equation into 2 smaller numbers. And I will give you a second to grab a piece of paper and something to write with if you need to do that, or a whiteboard and a whiteboard marker. And then I'll go ahead and show you what you're working on. And you can pause the video if you need to grab your materials. So here we are looking at the same equation, 3 times 6, the same expression. And I would like you to solve 3 times 6. By this time, instead of breaking apart the 3, like we saw in the last example with the carrots, break apart the 6. And so here I gave a little hint to get you started. Think about what you could break 6 into and what your 2 new expressions would be that you're solving to figure out 3 times 6. I'll give you a moment and then we'll talk about the answer. Probably we're thinking, well, Mrs. Nelson, you already showed that equation last time, so we know the answer is 18. And that's okay, because the whole point wasn't to figure out if you could remember the answer. It was to see if you could think about how to break apart the 6. So this is just one way, and there's more than one way that you could have done it. But one example I have here is by breaking apart 6 into 2 and 4 and figuring out what 3 groups of 2 is equal to. I drew a little array here, and then figuring out what 3 4s would be, and then adding those together, and we would get 18 as our total. So that's just one way you could have done it. You could have also broken the 6 into 3 and 3 and solved for 3 times 3 and 3 times 3 and added those together. Or breaking the 6 into 5 and 1. So there might be more than one way, and that's another cool thing about the distributive property. Okay, so that's all for today for distributive property, breaking apart a factor in an original equation to make it easier to solve. We will continue a little bit more with distributive property next time, and then we'll do some review with the other properties we've learned this week. Thanks again for joining me. For more practice with distributive property, try writing down some trickier facts like 5 times 6, 7 times 8, and then think about how we can break apart a factor and rewrite it as 2 easier facts to solve. I'll see you next time.
Hola niños y niñas, soy yo, la maestra Lorena Vázquez, una vez más, y hoy continuamos con nuestro aprendizaje sobre la multiplicación y sus propiedades. Como pueden recordar, hemos estado hablando que la orden de los factores no importan, pueden multiplicar 6 por 4 o 4 por 6 y el producto será el mismo. También, si tienen varios números que multiplicar, como multiplicar significa combinar grupos, no importa si multiplicas 3 por 2 por 5 en una orden mezclada. Entonces, hoy vamos a hablar qué hacemos para facilitar la multiplicación cuando tenemos factores que están un poquito difíciles. Quédense conmigo y vamos a aprender juntos. Comencemos. Bueno, niños y niñas, aquí estamos. Ayer estábamos estudiando sobre cambiar el orden en que multiplicamos los números para poder facilitar la multiplicación. Así que les dejé un encargado, una práctica por ahí. Vamos a repasar este trabajo que les dejé de encargo. El problema decía, la mamá de Mario compró 2 paquetes de 4 bolígrafos. Los bolígrafos son las lapiceras o las plumas. Su papá compró 4 paquetes de 2 bolígrafos. ¿Cuántos bolígrafos compró cada uno de los padres de Mario? Entonces, eso era como un repaso de la semana, ¿verdad? Si la mamá de Mario compró 2 paquetes con 4 bolígrafos, fácilmente podríamos decir que ese viene siendo 2 grupos de 4. Y para resolver este problema simplemente podemos contar los bolígrafos o podemos decir 2 por 4 son 8. Ustedes que ya han estado practicando. Y el papá de Mario compró 4 paquetes, así que hay 1, 2, 3, 4 grupos y cada grupo tiene 2 bolígrafos. 4 grupos de a 2 es también igual. Podemos contar de 2 en 2, ¿cierto? 2, 4, 6 y 8. 8 bolígrafos. Así que niños y niñas, aunque el problema sea 2 por 4, en el caso de su mamá, el producto sigue siendo 8. 4 por 2, también el producto es 8. Así que esto una vez más comprueba que el orden de los factores, el orden en que multiplicamos no importa. Bueno, comencemos con la lección de hoy. Hoy nuestra meta dice que estamos aprendiendo el orden de agrupación, hacer grupos para multiplicar, pero el enfoque es puedo descomponer números para multiplicar fácilmente. Todo lo que estamos haciendo aquí, niños y niñas, es para hacer las cosas más fáciles. Nuestra palabra del día es descomponer, así que cuando me escuchen decir descomponer, ustedes van a decir descomponer, separar en partes. Muy bien, vamos a intentarlo. Descomponer, descomponer, separar en partes. Excelente. Sus materiales que necesitan son los lápiz y papel, pizarra con marcador o cualquier otra cosa que les haga útil para hacer sus grupos. Comencemos. Primero quiero hacer un repaso leve de las tablas de multiplicación. Como les dije el otro día, un grupo de es una frase que podemos usar cuando estamos multiplicando la tabla del 1. 1 por 0, 0, 1 por 1, 1 y sucesivamente. Un grupo de 1 es simplemente 1. Un grupo de 2, entonces si yo fuera aquí a decir un grupo de 2 es simplemente 2. También cuando estamos multiplicando la tabla del 2, es simple hacer el doble. Así que 2 por 3 simplemente son 3 más 3. 2 por 4, 4 más 4. Y así. Entonces, algo que como ya aprendimos a sumar desde más pequeños y en tercer grado ya deberíamos de saber hacerlo en nuestra mente. Y como también sabemos contar de 2 en 2, quiero que miren los productos de la tabla del 2. 0, 2, 4, 6, 8, 10. Estamos contando de 2 en 2. La última estrategia que les quiero recordar, la tabla del 5. La tabla del 5 es simplemente contar de 5 en 5, la cantidad de veces que nos dice el factor. Por ejemplo, si estamos multiplicando 5 por 3, vamos a contar de 5 en 5 3 veces. 5, 10, 15. Algo que deberíamos haber aprendido en primer grado. Muy bien, entonces vamos a usar la tabla del 1, del 2 y del 5 para multiplicar y descomponer, separar en partes. Problemas de multiplicación y hacerlos más fácil. Así que vamos a ver cómo. Nuestro primer ejemplo. Vamos a decir que ustedes se enfrentan con el problema de 6 por 4. Y dicen, señora Vázquez, es que no he aprendido a multiplicar por 6 y mucho menos por 4. Apenas me estoy aprendiendo la tabla del 2 y del 5 y del 10 porque es fácil contar por esas cantidades. Les voy a mostrar una manera de descomponer, separar en partes. Excelente. Los factores para poder multiplicar más fácil. Aquí voy a escoger yo el 4. Aquí, este factor. Yo sé que 4 es simplemente 2 más 2. Entonces, si yo separo el 4, puedo decir 4 es 2 más 2, ¿verdad? Entonces, estos patitos que tengo aquí, hay 6 grupos. 1, 2, 3, 4, 5, 6. 6 grupos de patitos y cada grupo tiene 4 patitos, ¿verdad? Pero ya dije que eso es muy difícil. Entonces, fíjense lo que voy a hacer. No voy a cambiar la cantidad de patitos, pero voy a descomponer, separar en partes. Los factores. ¿Qué tal si yo separo el 4, las columnas, en 2 columnas y otras 2? Fíjense cómo. 1, 2 y 1, 2. ¿Cambié la cantidad de patitos? No hice nada, solamente los moví. Claro que no. Ahora yo puedo decir que aquí, en este lado, tengo 6 filas. 6 filas de a 2 patitos. Niños, ¿ustedes saben 6 por 2? Y ya sabemos que 6 por 2 es lo mismo que 2 por 6. Es lo mismo que 2 por 6. Entonces, si 6 por 2 y 2 por 6 es lo mismo, yo simplemente puedo sumar 6 más 6 y puedo hacerlo en mi mente. Acá tengo 2 columnas, 6 grupos de 2 patitos. Entonces, también aquí tengo 6 por 2. Niños y niñas, acabamos de descomponer este 4. Aquí está la mitad y aquí está la otra mitad. 6 por 4 es lo mismo que 6 por 2 más 6 por 2. Así que vamos a escribirlo de una manera diferente. Yo sé que puedo hacer 6 por 2 es igual a 12 y 6 por 2 es igual a 12 y 12 más 12 es igual a 24. Niños y niñas, este 24 me salió un poquito. Niños y niñas, 6 por 4, la respuesta es 24. ¿Vieron qué fácil? Pudimos descomponer, separar en partes. El factor de 4 y dijimos que era 2 y 2. y multiplicamos cada factor nuevo. Vamos a intentar otro ejemplo juntos. Aquí tenemos el problema 7 por 3. Señora Vázquez, de nuevo, yo no sé multiplicar 7 por 3. Nadie me ha enseñado, no he practicado. ¿Cómo podemos hacerlo? Pues vamos a hacerlo de esta manera. Yo sé que necesito 7 grupos. Lo voy a contar. 1, 2, 3, 4, 5, 6, 7. Y sé que en cada grupo necesito 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 2, 3. 2, 3. 2, 3. 2, 3. Si en casa me están viendo y tienen su pizarra y su lápiz y papel, por favor, dibujen esta matriz para poder hacerlo juntos. Ahora, 7 por 3. Puedo contar todos los puntitos, pero ay, ¿quién tiene tiempo para hacer todo eso? O de lo contrario, otra cosa que puedo hacer es descomponer el factor de 3. Este factor. Yo sé que el 3 es 2 más 1. Entonces, niños y niñas, podemos cambiar el problema y separar las columnas de esta manera. Podemos decir que tengo un grupo de 7 por 1 en cada grupo, más 7 por 2 en cada grupo. ¿Vieron cómo hice eso? Ahora yo sé multiplicar por 2. 2 por 7, fácil, son 14. Y 7 por 1, si yo tengo un grupo de 7, ¿cuántos tengo? Solo son 7. Así que niños y niñas, podemos decir que el resultado son 7 más 14. ¿Podemos hacer esa suma? Claro que podemos hacer esa suma. Podemos sumar las decenas porque podemos descomponer, separar en partes. Muy bien. El número 14 aún más. Este 14 de aquí, yo lo puedo descomponer y decir que son 10 más 4. Aquí. Ahora puedo sumar los tres números. Puedo sumar 7 más 10 más 4. 7 más 10 más 4. Y la respuesta es 21. Así que, niños y niñas, esta es la lección de hoy. Pueden ustedes ver los números y manipularlos o cambiarlos a su antojo para poder multiplicar fácilmente. Así que cuando miren un problema de multiplicación como 7 por 3 y no saben su tabla del 7, quiero que la traten de ver de una manera distinta. ¿Cómo pueden cambiar el problema o descomponer, separar en partes los factores para facilitar las cosas, para que no batallen tanto? Muy bien. Para mañana, quiero que intenten de resolver este problema. Recuerden, el orden de agrupación no importa. Podemos cambiar los números porque al final de cuentas multiplicar quiere decir combinar. Entonces, si yo combino todo junto al principio o combino este cachito con este cachito con este, no importa. El resultado, el producto va a ser el mismo. Así que tomen nota. Aquí va el problema para mañana. Georgina tiene 3 paquetes de 4 de marcadores. ¿Cuántos grupos? ¿Cuántos paquetes? Tiene 3 paquetes. 3. Cada paquete tiene 4 marcadores. 4 marcadores. Cada uno. Entonces, cada grupo tiene 4. ¿Cuántos marcadores tiene Georgina? 3 por 4. Ay, niños, yo no me he aprendido mi tabla del 3 ni la del 4. Apenas voy en la 1 y la del 2 porque son fáciles. Y la del 5 porque sé que puedo contar de 5 en 5. Quiero que piensen hoy cómo pueden descomponer, separar en partes. Uno de los factores para ayudarlos a multiplicar y resolver este problema. Y por favor, acompáñenme mañana para encontrar el resultado. Niños y niñas, hemos llegado al final de nuestra lección y hoy estuvimos aprendiendo que el orden de agrupación para multiplicar se puede ver de diferentes maneras. Recuerden, agrupar quiere decir poner en grupos, ¿verdad? Pero hoy dijimos que podemos descomponer, separar en partes. Muy bien, separar en partes los números o los factores para multiplicar más fácilmente. Entonces, eso es lo bello de las matemáticas. Podemos hacer con los números varias cosas para nuestro beneficio. Recuerden, podemos descomponer, separar en partes. Excelente. Los factores. Luego, sumar los productos de la manera que haga más fácil el problema. No olviden practicar sus tablas porque les estoy mostrando maneras de separar y mover los factores a su antojo, pero igual tenemos que practicarlas y saberlas de memoria. Mañana aprenderemos cómo descomponer, separar en partes. Muy bien, números para dividir, porque esta estrategia funciona para dividir también, ya que las otras dos que les mostré realmente solo funcionan para la multiplicación. Bueno, niños, gracias por acompañarme. Hasta la próxima y se me cuidan. Adiós.